Okay, so here we have number 2, which is find the point of intersection for the systems below without graphing. So here we have one system, so we'll start with A, right? Remember that a system of equations is 2 equations or more put together. So we have y equals negative 7x plus 12, and we have 3x minus 7y equals 20. I know that if I were to graph these, each of these would become a line, right? So y equals negative 7x plus 12 would be a line, and 3x minus 7y would also be a line because I see y, I see x. But it's asking me to solve or to find the point of intersection. In other words, to find where this line and this line will cross each other, to find that point without graphing. And I'm going to use the substitution method to do that because I could use the equal values method. If I were to use the equal values method, both of these equations would have to be in y equals mx plus b form. So that means that both of these would have to be solved for y. This one is solved for y already. This one is not. So I would have to subtract 3x from both sides, then divide everything by negative 7 to have y equals something, right? And I'm not going to do that because the substitution method is a little bit easier. The substitution method just asks for one of the equations to be solved for y or to be solved for x. This equation here is already solved for y. Y equals negative 7x plus 12. So I already know the value of y. The value of y is negative 7x plus 12. This is y. So here's where the substitution part comes in. Wherever I see y on the very next equation, which would be right here, I could take this, which is negative 7x plus 12, which is the value of y, and substitute it here. And that's exactly what I'm going to do. So I'm going to take negative 7x plus 12 and substitute it in for y on the next equation. And it should look something like this. 3x minus 7, and instead of y, I'm going to open up some parentheses here, which shows that I'm going to substitute for y, equals 20. So I already know the value of y. The value of y is negative 7x plus 12. So instead of writing y right here, I'm going to substitute negative 7x plus 12 right here. And that would look like this, negative 7x plus 12. And now, as you can tell, this equation here, instead of having two variables like these equations, this one has y and x, this one has y and x, this equation only has x. So now I'm going to finish this off and solve for x. I'm still going to use the order of operations here. Parentheses, I can't really do anything in here. Exponents, there are none. Multiplication, there is. I'll multiply negative 7 times negative 7x and negative 7 times positive 12. And that's going to look like this. Let's see. Negative 7 times negative 7x will give me positive 49x. Negative 7 times 12 will give me negative 84. And then I'm going to bring everything else down. Equals 20, and that 3x was right here. Okay, so let's continue with the order of operations. We finished multiplication. I don't see any division here whatsoever. Addition, yeah, I can add 3x and I can add 49x to that because they are like terms. So I'll take 3x, add that to 49x, and I'm going to get 52x. And then I'm just going to bring everything else down. Minus 84 equals 20. Okay. So I did addition. There is subtraction, but I can't subtract these two because they are unlike terms. So I cannot subtract. So I'm done with the order of operations. Now I got to move on to solving. In solving, I want to have the variables on one side and the constants on the other. So that means I want this guy by itself, which means I got to get rid of that negative 84. And I'll do that by adding 84. So plus 84 on both sides. And I see that these cancel each other out. Now I have 52x equals 84 plus 20 would be 104. At this point, I want the value of x, so I got to divide both sides by 52. And when I divide both sides by 52, I find that x equals 2. And at this point, some people might think, oh, I'm done. But you're not. Because what we're trying to do is we're trying to find the point of intersection. Any point has two values. A point has an x value and a y value. That's a point. So far, we figured out the x value. But we still need to figure out the y value. So to do that, I'm going to take this x, which is equal to 2, and I'm going to plug that value in here because that's the value of x. If I plug it in here, this will tell me the value of y. So let me take that equation, which would be y equals, let me write that a little nicer, y equals -7 times x, but instead of x, I'm just going to put parentheses here, plus 12. Now I'm going to take the value of x that we found, and I'm going to plug it in right here, which is 2. Let's see. Y equals -7 times 2 would be -14, plus that 12, -14 plus 12, y equals -2. So my point of intersection, it's at 2 and -2. Let's see if that's actually true. So when I graph the equations, see, like I took decimals and I graphed, oops, let me try that again. I graphed y equals -7x plus 12 and 3x minus 7y. I can see that the point of intersection is right here at 2 and -2, which makes this correct. By using the substitution method, I was also able to get x equals 2, y equals -2. Okay, let's move on to the next system of equations. So now we're going to do the same thing. We're trying to find the point of intersection for y equals x minus 1 and 6x minus 2y equals -22. I'm going to do this by graphing first, even though this says without graphing. I'm going to do it by graphing to see where that point of intersection is, and then we're going to do the substitution method again because I see that I have the value of y on one of my equations, so I can use the substitution method. So let's graph this first. Okay, so when I graph y equals x minus 1 and 6x minus 2y equals -22, I clearly see that the point of intersection, it's at -6 and -7. So I should get -6, -7 when if I do this using substitution as well. So let's try this using substitution. Okay. So I know the value of y. The value of y for one of my equations is x minus 1. So I'm going to use x minus 1, and I'm going to substitute this x minus 1 wherever I see y on my next equation. So I see y right here. But instead of y, I'm going to write x minus 1 because that's the value of y. So that's going to look like this. 6x minus 2, then I'm going to open parentheses instead of the y, equals -22. And instead of y, I'm going to write x minus 1. So now I just got to solve, again, using the order of operations. Parentheses first, I can't do anything inside. No exponents, so multiplication's next. -2 times x and -2 times -1, and that'll look like this. -2 times x will get me -2x. -2 times -1 is going to get me +2. Because a negative times a negative equals a positive. Everything else will be brought down, equals -22. And the 6x right over here. Okay, continuing with the order of operations, I don't see any division here. So multiplication and division are done. I don't see addition. Well, I see addition, but I can't really add these because they are unlike terms. Subtraction, I do see 6x minus 2x. I can do because they are like terms. So these two will combine, and that will get me 4x. Bring everything else down, plus 2 equals negative 22. At this point, I'm done with the order of operations. So now I want to have variables on one side, constants on the other. So I got to get rid of plus 2. And I do that by subtracting 2. So minus 2 on each side. And that's going to get me 4x equals, let's see, negative 22 minus 2 would be negative 24. Divide each side by 4. And I get x equals negative 6. So here we have the value of x, and that's exactly what I wanted because remember that the point of intersection was at negative 6, negative 7. So I'm hoping now that by plugging in this negative 6 here into x, I'm going to get the value of y. So let's try to do that. So I'm going to take this equation right over here, and this will become y equals x, but I'm going to use parentheses instead, minus 1. Remember that the value of x is negative 6, so I'm going to plug that in right here. That's negative 6. Negative 6 minus 1 would be negative 7, which is precisely what I wanted, because the point of intersection was at negative 6 and negative 7, just like we saw in the graph. Right over here at negative 6, negative 7. Okay, ladies and gentlemen, I hope this helped. I'll see you guys on the next video.